Welcome back to the channel AI with Sumit. So in our previous lecture, we have seen the random forest algorithm. Okay, its definition, its meaning in a simple way, that is forest of decision trees. Where and how the decision trees are going to be used in the random forest. For the classification problem, how the random forest takes the majority voting. For regression, how the takes average for the continuous values. Its proper working also, advantage, disadvantages, all things we have covered in our previous lecture. So I encourage you to watch the video. Now in our today's lecture, we are going to take an better idea about so support vector machine, that is SVM algorithm. SVM algorithm is also one of the supervised machine learning algorithm which is mainly used for the classification, but also it can be used for the regression purposes also. Okay, so it tries to find the best boundary. Okay, it tries to find the best boundary known as the hyperplane. Just remember the word. The boundary is called as the hyperplane that separates the two different classes in the data. Suppose, for example, a spam and not spam, cat or dog. So for classifying these data points, one boundary is drawn in between the two classes. That boundary is called as hyperplane. Let's see into this picture. Okay, let's see over here. It says that support vector machine is used for the classification and regression both. Okay, it works by finding the decision plane that separate the two different classes. Okay, so over here, suppose this is the class A and this one is class B. Okay, so it separates the two data points or two classes by drawing one line, which is called as the decision plane or hyperplane, we can say. Okay, so let's see in the second picture. What it tells the support vector and hyperplane. The support vector, what are the support vectors? The support vectors are the data points to the hyperplane, closest to the hyperplane. Okay, so over here, what are the support vectors? This one is support vector, this one is support vector, which are closest to the hyperplane. So okay, and that defines the class boundary. Over here, this points defines the boundaries. Okay, so this one and this one are the support vectors that define the class boundary, and the distance between these two boundaries is called as margin. Okay, just remember this distance is called as margin, and in support vector machine, the main goal or main aim is that to maximize the margin. Maximize the margin. Hyperplane is a plane that separates the two different classes. I hope you got an idea how the hyperplane is divided the two separate classes. What are the support vectors? What are the boundaries? And what is the margin? I hope you might have got a better idea about it. Okay, over here, yeah, support vector definition is also given over here also. That is the closest data point to the hyperplane, crucial for determining the hyperplane. Okay, so support vector machine is used for both linear and non-linear support vector machine. Okay, by drawing the straight line, by drawing this straight line, separate the two different categories or classes called as linear, or where we cannot draw the straight line. That problem is called as non-linear problem. Okay, and over here for classifying two different classes in the non-linear data points, we use the kernels over there. We use the kernels over there. How the kernel functions are going to be used for uh, classifying two different categories. Let's see over here. What is kernel actually? The function that maps data to higher dimensional space, enabling support vector machine to handle non-linear separable data. I hope you got an idea how the kernel working for the non-linearity. These are the some types where the kernel going to be used for different problems. If the linear separability is there, the linear kernel function is used. This one is a type of kernel. Okay, this is another type of kernel which is used for mapping the data into the polynomial space. If there is any need to map the polynomial data points, then polynomial kernel function used over there. Okay, this is the RBF kernel, that is radial basis function, which is the transform data into the space based on the distance between data point. It totally depends on distance between data point where RBF function is used. I hope just remember that kernel function is used for non-linearity SVM. Here is the main goal, which is maximize the margin between two different classes. Okay, maximizing this margin, this distance is should be the maximum, so that different categories are to be classified. And the larger margin is better for the model performance. So if the margin is less, then it might be the conflict or overlapping, or maybe the less perform of the model. And if the margin is larger, then model gives the accurate predictions, accurate classification for seen data also and unseen data also. Okay, so likewise support vector machine is going to be work. I hope you got the concept. Let's revise quickly. Support vector machine is a supervised machine learning algorithm which is mainly used for classification, but also used for the regression purposes also. It tries to draw a based boundary in between two different classes. Okay, that line is called as the hyperplane. There are some example like spam not spam cat dog. It is simple uh, graphical structure where we can analyze how the two different classes are classified by drawing the decision plane. Here are some concept like what is margin, that is difference between the two boundaries. What is the support vectors, that are the uh, data points which are closest to the hyperplane. Okay, and the distance is calculated by using the Euclidean distance formula. Okay, Euclidean distance formula. Okay, that is uh, square root of y2 minus y1 bracket square plus x2 minus x1 bracket square. This is the Euclidean distance formula. You can see over here. Okay, just focus over here. What is distance formula? Y2 minus y1 bracket square plus x2 minus x1 bracket square. What I have written over here, right? Totally Perfect. This is the Euclidean distance formula. By calculating these, or if you need to calculate the distance between the data point and the boundary, this Euclidean distance formula is going to be used. Okay. So just keep the things in your mind. That is, kernel function is used for the non-linearity separable data, and for the linear data, it directly classifies the data points by drawing the decision plane. Okay. These are the some points. Just remember the names: linear kernel, polynomial kernel, and radial basis function of kernel. Okay. So, and remember the main goal, that is maximize the margin between two different classes. I hope you got the better idea about the support vector machines. So that's it for the today's video. In our next video, we will go forward on the next algorithm, that is k nearest neighbor. So for the today's video, if any query you have, then just drop in the comment section. I'll try to approach your queries, and just keep in touch. Subscribe this channel for watching more videos regarding the machine learning. I'll implementing these algorithms also in our upcoming videos. That is the coding part. But first of all, just focus on the conceptual knowledge. Coding part is the further part. Okay, just go through the previous videos also for all the algorithms in the supervised machine learning algorithms. Okay, so that's it for the today's video. Thank you so much, guys. Let's see in the next video. Bye bye.